This is going to cover Oracle Database Curriculum Section 3, which is going to cover logical operations, kind of expanding on what we saw in the previous video. It's also going to discuss functions and sorting, so kind of a mixed bag of some things here. So let's take a look first of all and refresh a little bit, and never hurts to see it more than once. Some information from songs here. So you'll see that we have, various information about songs, and this is a good one for ands and ors because we have a lot of um, you know, different values to look at here, different columns. So let's say we wanted to see where genre equals rock and just get a list of those. And you can see Come Together, Stairway to Heaven. These are going to be considered rock songs. Everything has that genre set to rock, so looks like it's okay. You may want to remember to switch this up a bit just so it doesn't cut off after a certain number of rows. So notice that the genre, since there's one condition, it's easy. It just evaluates this as yes or no. We have the ability to also add other conditions to this. So we could, for example, find all rock songs that have a number of skips equal to 0. So it looks like, at least from what I see here, only Bohemian Rhapsody. There may be more since I had the rows limited. Let's give this a run. So yeah, one row. So typically adding in an and condition is going to make things a little more restrictive and cut down on the results more and more. Now, if I were to say, or this is going to be all rock songs plus all songs whose skips are equal to 0. So let's take a look at that. So, of course, Bohemian Rhapsody is there. And we also get Billie Jean here by Michael Jackson sneaking in. And the reason is because that one also has 0 skips, even though you could see pop is wrong. So with the or, it requires only one condition to be true, which also means the more or conditions we are, the more accepting we're going to be. So if we also then say, so we had, by the way, let's take a look, 22 rows. So let's say we throw in an or likes greater than 4,000. Now we're going to have 3 separate groups that show up here. The all rock songs, plus all songs with skips equal to 0, plus all songs with likes that are greater than 4,000. And you can see that we get Johnny Cash's version of Hurt showing up here. So that is not a rock song. It does not have 0 skips, but it does meet one of the criteria, so that it would be the way for us to do this. Now, again, there's always this argument of, well, can I just get all the information and pass it back to my Python or Java program and let that handle it? You can, but there are some concerns with that, and the big one is going to be size. Network speed ends up being something that slows down a lot of applications. So a lot of times, if you can get the most specific information in the query before you pass it off to another application, you're going to have better performance. So, um, but there's always pluses and minuses, but a lot of times you would do that. Other things would be if you want to minimize sending sensitive information. Obviously, this isn't really sensitive information, but if it were, restricting it in the query so the application never sees it and it never gets sent over a network would also be another big advantage there. Now, of course, if we were to go and turn this into ands, we get the Bohemian Rhapsody. But Again, the more conditions we add, the more restrictive it's going to get. And you can see Bohemian Rhapsody no longer qualifies because even though it is rock with 0 skips, likes were not greater than 7,000. It only had 6,000 in our database. So where things get a little more complicated, and maybe you've run across this in other programming languages, is when you start to bring out um, ands and ors mixed together. And that certainly does happen. So let's look at another example where maybe the ands and ors get a little more confusing and may lead to inconsistent results. So I'm going to delete this, and I'm going to write out what I'm looking for. We're looking for all songs with a genre of pop that have 9 million or more plays or 3,500 or more likes. So now if I say, let's start with the first part. So we're going to select everything from songs and the genre is pop, and we are going to get 30 rows. So if we only have 30 pop songs total in our database, that should be the upper end of what could possibly be there. Because when we put this other criteria on, we see that it looks like most of them, a couple of them, looks like Bad Blood has 2,500 likes, Levitating has 2,800, but they do both have 9 million plays. So we really should get about 30 results here. So let's throw this in. So it has to have pop and plays are greater than or equal to 9 million, or likes is greater than or equal to 3,500. And let's give that a run. And somehow that ends up with 61 rows. And just peeking around, Stairway to Heaven, which is a rock song, somehow qualified. And the reason is with programming, just in general, the order of precedence is not goes first. We don't have a not here, and goes first before an or. So not, then and, then or. So what the programming language is doing, just by the way that we've written this, is it is processing this like that. And what that means is you can qualify for either being a pop song with 9 million plays or more, or any song with 3,500 likes or more. And that's how Stairway to Heaven and Hurt sneak into this. They should not be here, but because it was written this way, you run into that problem. Now, honestly, if I'm writing this query, um, if I do an and and an or, I'll throw parentheses on there, even if they're not necessary, just to help whoever's coming after me to follow my logic. But in this case, just like if we wanted to do addition before multiplication, we can fix this by putting the conditions in parentheses. And this brings us 28 rows. So that did end up excluding 2 of our pop songs. So what this is saying is genre is pop, and one of those 2 conditions is true. But because this is now in parentheses, even though it is an or should go last, because the parentheses are there. This is going to make this get done first. So, so it's why it's not only important to write the query, it's important to have, you should know what the results look like at the end. And this is one example where those ands and ors being in the wrong order can certainly cause some issues. So, um, so just keep that in mind. Bad things happen sometimes if you don't pay attention to that ordering. Now, the next thing that we have is sorting. Also, you'll see people call it order by because that's the command we're going to use. Um, Order by is going to come after the where. Now, there is as we get into more and more of these terms, there is a mnemonic device. Some French waiters grow healthy oranges is what it's called. So if you go out there, that's to remember what order the keywords are. So some French waiters grow healthy oranges. It's just, a way to remember the order of these. So we're going to be discussing order by. We haven't mentioned, um, you know, grouping and ordering or in having. We'll get to that. But when we talk about order by, that's always going to come after that where statement. And as a matter of fact, it really should be your last statement there. Now, um, let's take a look here and let's say we want to sort. And by the way, we don't even need the where. Um, let's say select star from songs. And let's say we're going to order by plays instead of whatever our default sort is, which is usually the primary key. And you'll see that Blowing in the Wind is the low one there. And Billie Jean and Blinding Lights are tied at the top. Now, you'll see that by default, it's going to sort in what we call ascending order. So ascending order is going to be low to high. So we're talking about sorting by characters. It's A to Z also. Um, Dates, ascending order would be oldest to newest. That word ascend, if you're talking about like a ladder, you're ascending, you're climbing up, and the opposite is descending, climbing down. So um, you don't have to do anything to get it to sort low to high. Um, but you can go in there and say DESC for descending order, and you can see that it turns red, which is going to indicate this is, a keyword there. I'm being careful not to highlight things because, it happens, and we can see it shows up there. Now, this is the way that we would order this way. We can go in and say descending order and do it that way. Now, the one negative of sorting by a single column is going to be if there are ties, maybe things are not going to be quite as obvious. Now, this database doesn't have an exact example of this, but let's say I was sorting a roster for my class and we go through the roster. We have multiple people with the same last name. If we just sort by last name, you're not going to be sure which of these Castillos would show up first. So what you would typically do is you would add a second level sort. And we could do that by adding a comma in here. So in this case, we're sorting by plays, but what happens if there are songs with the exact same number of plays? What might be a second thing we might want to sort by? And I might say, let's sort by the song title to do that. Now remember, the default for each of these is going to be ascending order. So if I do this, we're going to get the exact same 80 rows. It's just going to tweak the order a little bit. Billie Jean and Blinding Lights were already in alphabetical order. I should have called that out before, but I promise they were. Because alphabetically, Billie Jean comes first. But you could see I Will Always Love You is now in front of Not Afraid, which is in front of Shape of You. And again, if we did not have that, the sorting by number of plays is exactly the same, but it gives the database a little more instruction. What should we do if there are people who have the same amount of plays? What is our secondary sort? And again, if we're doing a roster, it's last name, first name, probably middle initial, and then all other things being considered, um, student ID. Because I have had multiple students named Armando Martinez, Carlos Castillo. There's a lot of people with the same name over my career, so that could certainly be a challenge. Um, so, um, but again, if we throw in the song title as a secondary sort, that should be good. And the nice part about song title is that should be relatively unique. So we shouldn't run into too much confusion there. Let's say we have a calculated field. And let's say we take likes minus skips and we call it something else, normalized likes. We're database people. We like normalization. And let's throw in the song title so it's not just a bunch of numbers. Now, because of the way that Oracle and all queries are going to execute, we can use this calculated field as part of the ordering because ordering is what is done. That's the last step. So even though this is not a real field in our table, because it's been calculated as part of this query, I highlighted, because it's been calculated as part of this query, we can see it does in that order. And again, I would probably go descending because I probably am more interested in the positives here. And you can see you've got, I think this song had maybe 11,000 likes. We have one skip, so 10,999. So we can also sort by our own customized columns if necessary. Now, the other hidden sort feature is going to be that even if it is not in the in the select, you can use it to sort as long as it's in that table. Now, you'd probably want to put a good title on this just because otherwise it just looks like an unalphabetized list of songs. But if we do this, we will get a list of song titles ordered from highest to lowest. And there we go. And of course, we can throw in that secondary sort. Song title just so um, the other songs there's somewhere around here. Those will be resorted appropriately. So again, if you have no context for what this means, maybe we don't know what this means, but the point is you can sort by stuff even if it's not part of the query. So now the last section of the curriculum is going to discuss functions. Now I'm going to show a couple, but I'm going to stick with a couple because we do some of this in the next section. There are going to be a lot of different functions, and I'm just going to just to show you how many there are. You'll see a lot of times they are categorized into either single row functions and aggregate or multi-row functions, but like there are XML and JSON functions. This would be like if you want to format something for the web. Date and time conversions are a big thing. Let's peek at just numeric and character real quick. So just like you would find with Python, Java, you include or import a library and you get access to certain functions. Numeric functions are things like absolute value, tangent, all your trigonometry functions. Those are going to be things that definitely show up. And you might say, well, when is anybody ever going to need this? I worked on an aircraft defense system, one of my first jobs out of college, and we did have to do a lot of calculating of angles. Like, okay, we've got a signal coming in. What is the angle? And you did actually have to use these trigonometric functions. I do hope you don't have to, but if you do, they are there. Another one is going to be rounding. That's a good one. And then character functions. We have knit cap, we have lower, we have padding. There's a lot of these. Again, I don't want to go. I'm just trying to point out that this page has a lot of these. And the other thing that becomes a challenge is these are not always going to be the same, going from one tool to another. And I will put this in the video description if you want to peek at this ahead of time. So, for example, let's say we want to uppercase. And you can see that that would uppercase the song title. And there are times where this might become useful, where let's say, there are certain songs that are stylized a little weird sometimes, where maybe the first character is not uppercase. See if we have an example of that. I think everybody is pretty standard here. I've got a couple that are all uppercase. So if I were to say, I'll get rid of the ordering since we're really focusing on the functions here. Notice humble shows up for capital U, but it does not show up for that. How do I get both of those would be the question. And the way that you can do that is you can also use the functions here, and you can apply that to the query, to the criteria of the query. And notice that if we do this, we uppercase the song title and then compare it to a pattern. Now we get both of them. So this would be, an example of a string function. This is how you basically find, I think I may have mentioned there's ways to get in case insensitive, like how do you do something if you don't know if it's upper or lowercase. This is how. Now, we don't really have anything that's really roundable in our results here. So I'm going to make something up. So let's say we take plays divided by three. Nothing ever divides evenly by three. And we could see that we get some, I mean, some do, but we got a lot of ugly looking values. Notice that it's called plays divided by three for now. I don't really care about that. But there is a numeric function called round. And you can see that will round that so we don't get those ugly decimal places. And there are other ways. You may have seen this if you did Python, Java. There's very similar functions, and you can usually also give it a number of decimal places. So we could kind of standardize the way that works. Again, this is a built-in function. We don't have to include or import or do any of that stuff. So, but again, these will be covered kind of in section 4. And some of them even a little further. Now, the other type, multi-row functions, this will be covered a little later, but let's take a look at one of those. Instead of doing one result per row, these are going to be also called aggregates. So what that means is if I do a sum of plays, instead of getting one row for each of the 80 songs, we're going to get one row for the entire table. And we can see that is the number of plays that shows up there. So there are ways to kind of do more with this, which again is going to be in a future video, but the common ones that you would find are sum, average, min, max, and count will just tell you how many. And this will tell you, all this type of aggregate information about that. So this covers section 3. Hopefully this helps get you set up for this week's assignment, and I'll be in touch soon. Take care.